Hello and welcome to the next episode of Python for Chemical Engineering Calculations. Today I'm going to continue talking about Python functions and give you an example of a Lambda function, a special way to introduce function in a short notation, and also show you what a recursive function is. But let me start from the example which I covered in a previous video. So let's say we want to calculate a very simple function f of x is x squared minus 2x plus 1. So given x, I'm calculating y. And the way to go would be, well, I'll call it f naught. I guess the simplest way to do it is to introduce a variable y and to say y equals x squared minus 2x plus 1, right? And then I do return y. If I now call my function, I introduce x and call my function with a certain x, I hopefully will get an answer. Let's say x is 2. I want to print f naught of x. Right, if I run it, it gives me 1. First thing I can change here is I actually don't need this variable. I can do the return. So let me introduce f1 of x, which will do exactly the same thing as f naught. I do return x squared minus 2x plus 1. So I'm not even creating my y. I'm returning the result of this calculation right away, which is, if we don't need to perform many different operations, which makes it shorter, which makes it simpler, right? So now if I do print f1 of x, x has been defined here, right, and run it, I'll get the same result. Well, in Python there is another way to do it, which is even shorter, without even this def keyword. It uses another keyword, lambda. So the function is introduced in one line, and this is very convenient for functions like this one, when you need to do several simple mathematical operations. So I introduce in my function f2 as a lambda function, and the syntax is the following: lambda x, where x is the input variable. Here I type the calculations which I'm doing for the output. So this is equivalent to this. And let me demonstrate that. I'm doing print f2 of x. And if I run it, getting the same result. Well, in terms of how to organize the code, here I have a definition of a function, then I call a function, then another definition. To make a code more organized, typically we put all the function definitions in the beginning of the code, and only after that we perform certain manipulations and call these functions which we defined at the top. Okay, there is one more thing I want to show in this video, and this is a recursive function. So I can erase all that, I won't need it. And let's say I want to calculate n factorial, right? N factorial is introduced for integer numbers, so it's the product of n times n minus 1 times n minus 2 times etc. times 1, right? And the 0 factorial is by definition 1, right? So let me introduce a function which calculates that for an arbitrary integer n. I'm going to call it factorial. N will be my input parameter. I will introduce nf, the variable, which I will return as a result. And I need to do a for loop for I in range n. I'm taking my nf and multiplying it by I'm starting from 1 and I'm going up, so I'm not writing it this way, but I'm writing it the other way, right? So it's 1 times 2 times 3, etc. times n minus 1 times n. So I'm taking my nf and I'm multiplying it by I plus 1. One thing I want to illustrate here is also the short notation for this. So instead of writing nf equals nf times something, I can write nf multiplied equal I plus 1. These two lines are equivalent. After I finish my loop, I return NF. Okay, I can run it. Well, obviously it's not doing anything because I never called my function. All right, let me say n equals to 3, and I want to print my factorial of n. Let me do that. Well, I get 6. Well, if I change it to 5, I'm getting 120, so looks like it works. There is another way to implement it. So factorial, what it does, it uses, well, if you think of these manipulation on each of the next steps, it uses the result we get from the previous step. In such case, recursive function becomes convenient. The recursive function, what it does, it calls the function calls itself in a sequence using the result of the calculation from the previous step. Let me show it how it works, and I think it will explain it. All right, so let me comment this out and introduce another function. Call it factorial r recursive. It also is going to have one input parameter of n, and then this factorial function, all it needs to do is to return n times the factorial of n minus 1. So if we think of how this code will be executed, if we have, let's say, 3, so n equals 3, so the function will return 3 times, well, factorial of 2. Well, factorial of 2 is called, so then it will get back here and then return n times n minus 1 times n minus 2, etc. The problem is the following, so we don't know what to do once we get to n equals 0, right? And at this point, this is where these definitions comes into play, and at this point we need simply to return 0. So what I'm doing here, I'm saying if my n is equal to 0, I'm returning 1, else I'm performing this multiplication. Let me call these, well, I can uncomment these lines and change this to factorial r and run the script, and I'm getting the same 120 as a result.